Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about importance of organic chemistry. So what is organic chemistry? Organic chemistry is a study of carbon compounds. Organic compounds have carbon and hydrogen. Carbon dioxide is not organic. Now, the versatility and stability of carbon's molecular structure provides the enormous range of properties of its compounds. My friend, carbon can bond to other carbons. Reason for the degree of structural complexity. Now, friends, ridiculous complexity. I will show you a very big molecule. Why it is big? Because number of carbon, number of hydrogen, number of oxygens, number of stereogenic center, number of stereo centers, number of double bonds, number of nitrogens, number of functional groups, all are present in this molecule. And what is the name of this molecule? Palytoxin. Palytoxin, made by a species of seaweed and coral. And this compound was synthesized by Kishi at Harvard in 1994. Now you think about this molecule. The drawing is difficult. Looking the number of carbon atom is difficult. How our scientists synthesize this compound. So this compound is an organic compound. Now, organic chemistry, carbon. You know about the carbon? Carbon has 4 valence electrons. Carbon makes 4 covalent bonds to fill its octet. Can include double and triple bonds. Hydrogens, compound with only carbon and hydrogen. So, organic chemistry in everyday life. I will give you some example. Then you will satisfy the importance of organic chemistry. Smells and tastes, like fruits. You all know fruits. You have daily routine to taking the fruits. Fish and mint. Medications, you know, aspirin, Tylenol, decongestants, sedatives, insulin. Addictive substances like caffeine, nicotine, alcohol, narcotics. Now, my friend, you can see the hormones and neurotransmitter, adrenaline, dopamine, serotonin. My friends, food. You know, carbohydrates, protein, fat, vitamins. My friend, you know the genetics, DNA, deoxyribonucleic acid, and RNA, ribonucleic acid. Now, friends, you know the consumer products like plastics, nylon, rayon, and polyesters. From these examples, now I think you are interested to learn organic chemistry. Now, organic materials. In addition to previous notes, Before it was stated that covalent compounds were mostly liquid gas at room temperature. This is primarily for binary compounds, two elements. More complicated structure can be solid at room temperature. Now, general formula. You know about the alkanes, contains only single bond, CnH2n plus 2. Alkene contains at least one double bond, and alkynes contains at least one triple bond. So alkene and alkynes are more reactive than alkane. Now I will talk about saturations. What is saturated? Saturated, a carbon chain contains as many hydrogen as possible. Saturated compound contains only single CH bond. Alkanes are saturated. Unsaturated means that a carbon chain contains at least one multiple, double or triple bond. For example, alkene, double bond, and alkyne, triple bond. Now, you can see hydrocarbons. I pick name: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Molecular formula: CH4, carbon 2, hydrogen 6, ethane, carbon 3, hydrogen 8, propane, carbon 4, hydrogen 10, butane, carbon 5, hydrogen 12, pentane, carbon 6, hydrogen 14, hexane, carbon 7, hydrogen 16, heptane, carbon 8, hydrogen 18, octane, carbon 9, hydrogen 20, nonane, carbon 10, hydrogen 22, decane. Now you can see the structural formula. And the most important parameter, you can see, start from the minus, now positives. So what happened here? Temperature of boiling point is increasing as number of carbon increases. Now, structural and physical properties. You can see the structure of methane, the structure of ethane, the structure of propane, and the structure of butane. Now, you see the 60 gram per mole, 30 gram per mole, 44 gram per mole, 58 gram per mole. So larger molecular mass, higher boiling point. Bigger compound, higher boiling point. Now petrochemicals. Simple, small hydrocarbons are petrochemicals. Chemical isolated from crude oil, petroleum. Octane used in gasoline, propane used in grills and heaters, butane, lighter fluids. Now, friend, function groups. Function groups, group of atoms which control how the molecule reacts. Group of atom. This is very important. People asking, what is the function group? Then the student replying, the examples of function group. No, you give the exact group of atoms which control how the molecule reacts. So you can see hydrocarbon derivative without carbonyl. Hydrocarbons means haloalkane, alcohol, ether, amines. Hydrocarbon derivative with carbonyl, aldehyde, ketone, carboxylic acid, ester, amides. Now polymers. You know, my friend, large molecules with many repeating units made up of small molecules. You can see this is the polyethylene. Polyethylene. Nylon, Kevlar, and PVC, polyvinyl chloride, are other examples of man-made polymers. You can see the structure of nylon, you can see the structure of Kevlar, and you can see the structure of PVC, polyvinyl. Now, friends, natural polymers. You can see proteins. These are the amino acids. You can change the R, and these portions make the peptide bond. So this is the dipeptide after removing water. You can see the structure of RNA, ribonucleic acid. You can see OH group is there, OH group is there. So this is the ribose. That's why it is RNA, ribonucleic acid. This portion is 3' in and this portion is 5' in. Why 5' in? You can see the numbering scheme of your sugar. 1', 2', 3', 4', 5'. So this phosphate 5' that is. This one you can see here 3' and this is the 5'. So this 3' is attached with this here. So this is the in. So 3'. Now DNA, you can see deoxy, here no oxygen at 2 position. Here is also no oxygen. So this is the DNA, deoxynucleic acid, ribonucleic acid. This is 3 in, this is 5. Now you can see the polysaccharides, many glucose units and mono substituted monosaccharide combined together forming cellulose polysaccharides. Now friends, pharmaceuticals. Most pharmaceuticals are complex organic molecules. Can be natural or man-made. You can see the structure of aspirin. Aspirin, you can see 2 functional groups. One is the ester, another carboxylic acid. And this ring is the benzene ring. So you have 2 functional groups in aspirin, carboxylic acid and its derivative. Now you can see the structure of penicillin. You have many functional groups here. Here 2 nitrogens. This is the 3-degree nitrogen. This is 2-degree nitrogens. You have the amide here, substituted amide. You can also hear the substituted amide. You have the carboxylic acid. You have the thiomercatrans like that. So a lot of penicillin. You have the 5-member ring. You have the 4-member ring. Now you can see the acetaminophen. Acetaminophen, acetylene, it is common name, Tylenol. You can see this is the substituted amide and alcoholic functional groups. These are the medicine, aspirin, penicillin, acetaminophen. So term you should know always if you are interested in organic chemistry. Hydrocarbon, you learn what is the hydrocarbon. You know the alkenes, alkene, alkynes, saturated, unsaturated, petrochemical, function group, and polymers. So my friends, skill to master, differentiate alkane, alkene, and alkyne, differentiating the saturated and unsaturated compound, differentiating the natural polymers and man-made polymers, recognizing the common pharmaceuticals. So friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, share it in your friend circle so that every person will be benefited with this video. I am making this video only for you. So thanks for watching.